Okay, so let's talk about the unit circle in sixths. So we've done fourths, we've done halves, we've done thirds, and now we're going to do sixths. And it's a little bit deceptive because what we're really doing is just taking half the circle and dividing it into sixths. The whole circle's divided into twelfths. So we know, let's go ahead and just count this off. So this distance from here to here is pi over 2. This whole distance is pi. So if we cut it into sixths, each of these sections is pi over 6. So that's 1 pi over 6. This is 2 pi over 6, which is the same thing. Oops, I have a 3 there. Should be a 6. 2 pi over 6, which is the same as pi over 3, reducing it. So notice I have my thirds within my sixths. So 1 pi over 6, 2 pi over 6, 3 pi over 6, which is just pi over 2, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, 6 pi over 6, which is just pi, 7 pi over 6, 8 pi over 6, which is just the same as 4 pi over 3, 9 pi over 6, same as 3 pi over 2, 10 pi over 6, 5 pi over 3, 11 pi over 6, and 12 pi over 6, which reduces just to 2 pi, and that's what I would expect to go all the way around. So when we're looking at this, we can look at the wrapping function in sixths this time. And so we don't know the exact point for pi over 6. We do know 2 pi over 6 because it's the same as pi over 3. So we did that in a previous video where we found that was 1/2 comma square root of 3 over 2. But we can say equivalent wrapping functions. So the wrapping function of 5 pi over 6 is equal to, if we were to wrap it around one more time. So if we go to 5 pi over 6 and we go all the way around the circle, or 2 pi, we're going to get back in the same place. So that's equivalent to the wrapping function of 5 pi over 6 plus 2 pi. 2 pi I'm going to write in terms of sixths, so it's easy to add. That's 12 pi over 6. So when I add them, that's equivalent to the wrapping function of 17 pi over 6. I'm going to end up in the same place. So I can also subtract 2 pi. I can be at 5 pi over 6, and I can subtract 2 pi from it. If I subtract 2 pi, I'm going to go all the way around the circle backwards, and I'll end up right there. So the wrapping function of 5 pi over 6 is equivalent to the wrapping function of 5 pi over 6 minus 2 pi, changing it into 6, 5 pi over 6 minus 12 pi over 6, that's just 2 pi. That gives me a negative 7 pi over 6. So I can go negative 7, so here's 1, 2, 3, 4, 5, 6, 7. And I would end up right back there if I were to wrap it negative 7 pi over 6. I would end up in the same place, that same point. Now let's talk about what those points actually are. So we did that with fourths and we did it with thirds. Let's take a look at sixths, and we're going to do it in much the same way. We're going to draw that triangle in there. So this is a reference triangle. Since I'm cutting pi right here into 6 pieces, I know this whole thing is 180 degrees divided by 6, and I have 30 degrees. So this is 30 degrees right here, and this is pi over 6. So this right here is my radian measure, pi over 6, and I know this is going to be 30 degrees. I know this is 1. It's just my radius moved up. So this length, my hypotenuse, is 1. Across from the small angle, my 30 degree angle, is half my hypotenuse, which is just 1/2. And then my long side across from the 60, this is 60 degrees because this is a 30, 60, 90. Across from the 60 degrees is rad 3 over 2 because I'm taking that 1/2 times rad 3. So now I have my x distance and my y distance. Now notice this is related to my pi over 3 triangle. It's just turned on a different side. And so what's happened here is now my x value, rad 3 over 2, was what my y value was for pi over 3. So I have rad 3 over 2, comma, my y value is 1/2. So I didn't go up as far as I did with pi over 3. And that's a good way to check to see if you have it written correctly. So here I have rad 3 over 2, comma, 1/2. Now if I take that triangle and flip it over, notice it will be the same triangle over here This distance, however, will be negative. So my x value will be negative, rad 3 over 2. My y value will be positive. Oops, my y value right here will be positive. It'll be positive 1/2. And I can do the same with my other quadrants. So here I have 7 pi over 6, and that's negative rad 3 over 2, comma, negative 1/2. Both are negative. And notice they're just the opposite of my, they're switched places, the x and y switched places from my 4 pi over 3. And then over here at 11 pi over 6, I have my x value being positive, because I'm going this way, and I have rad 3 over 2, and my y value is negative here. So that's negative 1/2. So now let's talk about the wrapping function, and we'll actually get a value out. So if I have the wrapping function of 11 pi over 6 radians, I'm going to go around the circle 11 pi over 6, which is really close to 12 pi over 6. It's not quite. This is 12 pi over 6. Here's my 11 pi over 6, and I get out a point, which is just rad 3 comma negative 1/2. Now my wrapping function for negative 8 pi over 6, you can reduce this fraction before you wrap it. So I just reduced this fraction, and now I have negative 4 pi over 3. And I could go count backwards if I wanted to on my pi over 3's. So I have 1, and then I have 2, and then I have 3, and then I have 4. So that's just 2 pi over 3, which would give me this value, negative 1/2 rad 3 over 2. It's a little bit tricky in there because you have to remember with your pi over 3, you can't count this middle line as a pi over 3 because it's not going to go into those halves right there. You can't write that in terms of thirds. And so it skips over that line right there. So it's a little bit tricky, but you could do it that way. The other way is you could add 2 pi to it, and it would make it a positive number, and it would be one that's on our circle. And I can add 2 pi to it because I'm just going all the way around the circle, and it will wrap in the same place. So 4 pi over 3 plus 6 pi over 3. I changed it to thirds, gives me 2 pi over 3. So then I can go to 2 pi over 3, and I see that it's negative 1/2 comma square root of 3 over 2. So now let's look at a bigger number. So if we have the wrapping function of 27 pi over 6. So that's a lot. And I would like to take it down. I mean, I could count through the 6 27 times, but that would take a long time, and I also might make an error. So I'm going to go ahead and just subtract 2 pi from this until I get a number that I'm more familiar with. So I have 27 pi over 6. I'm going to change it to sixth. So I'm going to subtract 12 pi over 6. I'll end up in the same place. And that gives me 15 pi over 6. 27 minus 12 is 15. So now I have 15 pi over 6. And I'm going to take that and I'm going to subtract 12 pi over 6 again. So I'm just going around the circle again in the opposite direction. So 15 pi over 6 minus 12 pi over 6 is the same as 3 pi over 6. So 3 pi over 6 reduces to pi over 2. So that's a familiar one. I can look at pi over 2 and say that is 0,1. So that makes it a little bit easier. If you have a number like this that you don't want to wrap around, you can either add 2 pi or subtract 2 pi. And until you get a number that's going to, that you're familiar with or is easy for you to calculate.